All right, here we go. Unit 2, Day 2. What we're going to talk today about is, and I did put a new calendar on Google Classroom, FYI. Unit 2, Day 2. The two questions that I have for you today is, how does the solution on an inequality look different or look the same as that of an equation? So an equation is this, equal sign. Inequality is less than or greater than, less than or equal to, or greater than or equal to. How do they look different? And what type of questions would lead to an equation versus an inequality? Okay. This quick little presentation is how I want to run class going forward. It's called Think Time 1 and 2. I ask the question, you form the response. What do you think? Okay? I will call on you randomly, so don't raise your hands anymore. You don't even have to worry about that. So, during Think Time 1, you're going to listen to carefully to the question that I have. You're going to give time to think about it silently. Don't raise your hand. There's no need to, because I'll call on you randomly. And then wait for the teacher to call on someone. Be prepared to respond out loud. And again, when you're responding, everyone is listening carefully. If not called on, listen carefully to my classmates' response and think about it. Guys, number 6 is probably the most important thing up here. Sometimes when someone else is talking, we might zone them out. We're like, I'm good. I don't have a question right now. But here's the thing. What they're saying could actually strengthen you. When you guys are in groups, the reason why I want you talking is because the way you might say something to someone makes the light bulb turn on. And not only that, it helps you to yourself by explaining it and making sure that you know it well enough yourself. Okay? So, tell students to share the response. Respond if called on. Listen carefully if not. Think Time 2. I'm responding to the question. I continue thinking during the pause. I add or change my response if appropriate. So as someone is saying something, you might change what you were originally going to say. So let's say I'm about to call, let's say on Caleb and Noah. And I call on Caleb first, and Caleb's giving an answer, and Noah's thinking about what Caleb is saying right now, and at the same time, what was he thinking? He possibly might add or change or alter, and that's what this is talking about. So my classmate is responding to the question. We all quietly think about the classmate's response. Do you agree? Do you disagree? And why? Think about it, how you can add to their answer and be prepared to add your comments if you're called upon. Listen to all comments respectfully, okay? And carefully, of course. Provide feedback, ask more students to respond is what I'll do. More students respond and allow others to listen to all others listen to the responses. And then the last one, the big takeaways are this. Students who are quiet, more reluctant students, they have a voice, because I need to know what you understand. I need to know what you know, okay? And we build from that. Bullet 2, students want to raise their hand, but understand that they don't have to. Just wait. I will call on you. And then more student interest in peer responses. That's a huge one. You're listening to, how does your peer understand this? What is it to them in their world? And it could affect your understanding and what it is in your world. More developed answers is the key when they have time to process. All right. So it's not just being quiet and being respectful. It's also listening and learning from those responses. All right. So we just did the warm-up. We just did the warm-up as far as doing the independent, dependent, and inconsistent forms of systems of equations. Okay, so now what I want to do is I want to go to these notes that are dealing with linear programming. Or sorry, not linear programming, inequalities. So go ahead and grab this sheet out right here. And it is, let me pull it up. Okay, so we're looking at linear inequalities. Guys, linear equalities are just a small extension from what we already know with lines, okay? So, linear inequalities have these symbols, and you could say equalities, if you will, have the equal sign. Now, let's go to this graph right here in step 1. We're going to write the equation. Look looking at this graph, anyone, what would you say the slope is of that graph that's in front of you? 2/3. So let's go ahead and write 2/3 as the m. And what's the b? -2. So my answer is 2/3 x minus 2. That is my equation like a line. Okay? And if I jump to that over here and I have the same line, the difference lies right here. If it's equals, it's solid. If it's an inequality without the equals, it's going to be dashed. Okay? Now, so we're going to say shade what line for greater than? What does that look like? We're going to shade, anyone? Above the line. Okay? We're going to shade below the line. Guys, if you struggle to see above or below, most people struggle on equations that are really, really steep. Because if I said shade above that line, a common mistake people make is they go to the line and they think above means this way. So they'll shade all of this. That's not shading above. Shading above looks like this. Pick a point on this blue line, and basically you have an option of going above or below, up or down. So if you're going to shade above a very steep line, I want you to use this kind of method so that you make sure that you shade correctly, which is above. Okay? All right. So our second equation. This equation right here, what's the m? What's the slope? -2. And what is the y-intercept? 3. So this would be -2x plus 3. The same over here. -2x plus 3. The only difference is, again, notice that it has the inequality symbol. If you don't see equals, if it doesn't have that equals, it's going to be dashed. Okay? So what I want you to think of, remember, just like we did before, these mean brackets. These mean parentheses. Otherwise, an open dot and these are like closed dots. So what you're putting this information with what you're learning today is if you have an inequality that looks like this instead of an open dot, it's like you have an open line. And over here you would have a solid line. Okay? Alright, and then the other thing, of course, is to shade below or above. Any questions right now for what we have? Okay, so let's go to step 2. A blank line means solution is greater than or less than the boundary line. What would I put there? A dot, a dashed, yeah, a dashed line. And then right here is a solid line. Means the solution blank the boundary line. What do you think goes in that blank? Includes for sure. Includes, that's huge. If it's on a dashed line, it's not included as an answer. But if it's on a solid line, it is included as an answer. So when solving for systems of inequalities, the double shaded area is the solution. You with me? So in this case, we have y is greater than or equal to, what equation would go here? Anyone? -2/3 x plus 3. Right? And then the other one, 2/3 x minus 2. Those two equations. Now, watch real quick. This is all what it's all about today. This right here is this line. And I shaded above, including the line. Okay? The other one is right here, and I shaded above this line. And I know you can't do this on your paper, but you notice the overlap, the shade that's overlapped, that's the answer. So let's go back a little bit. What we've done before, what we did with warm-up today, an independent system of equations has how many answers? 1. An inconsistent system of equations has how many answers? 0. And a where they lie right on top of each other, a dependent has how many answers? Infinite. How many answers can we have with inequalities? I could have one answer. I could have two answers. I could have three answers. I could have 20 answers. You with me? And I could also have infinite answers because it's including the shaded regions. Are we good? Okay.
If you have 0?
No, you have to have at least one answer because you have shaded regions overlapping each other.
But like, what if they were like parallel and it went this way and this way?
Ooh. Nicely done. So look at this. What if I have equations that look like this? But then on this top one, I had this. And on the bottom one, I had that. So I stand corrected. Marcus is absolutely correct. You would have no answers on this one. Because the answers are, where do those cross? And or where would those overlap and shade together? Okay? Here's what I'll say, Marcus. I've never seen one like that. But you are absolutely right. If you had one like this, it would be no solutions. Okay? Alright, so let's go back. And we go to okay, so the next part where we're going to look at are actual examples, okay? And then I'm going to ask you the pinnacle or the word problems. The word problems can get a little bit tricky, but they're not that bad. Let's go ahead and start. We have example number 1. I want you to help me solve the following system. The following system of inequalities is 2x minus y is greater than or equal to negative 3. I also have y is greater than or equal to a negative 1/2 x plus 1. Okay. So with this, we're going to graph these by hand from what we learned today and find all the answers that exist. Okay. Which one of these can I graph by hand right now because it's ready to go? The bottom one, right? Okay, so how do I do that? Parker, how do I do it? Point at 1 for its y-intercept, and then? Down 1, what direction 2? Right, yes, so down 1, right 2. Down 1, right 2. So on and so forth. Nicely done. Chet, is this going to be a solid line or a dashed?
Solid.
So it will be a solid line. Okay, so let's go ahead and go to the solid line. And it'll look something like, oops, let me do this in red. Alright, Katie, what direction do I shade?
Right.
Okay, careful with this. Up or down, above or below. And it's okay, it's okay. It's a common mistake. She's not the first, she won't be the last. What direction do I shade?
Up.
Up. I'm going to shade above. So we're going to come over here because y is greater than, that means we're going to do greater than or equal to. So we're going to include this line and everything above. Okay, Ethan. That one's done. What do I do next? Okay, so perfect. We have to get the other one in the same form in a y equals mx plus b form. Ethan, what's the first step to do? Subtract 2x. So we have this. Porter, from here, what do I do? Porter. What do I do to get this and finally y equals mx plus b form?
Times the negative.
Times the negative. We're going to multiply both sides by a negative 1. And we have to change the sign. If you don't remember this, please put big O huge asterisks because you have to remember that is a common mistake that will be tested. So y is less than or equal to a positive 2x plus 3. Okay, so I'll come over here to my graph And at a positive 3 is my y-intercept in a rise over run of 2. So up 2 over 1. Or down 2 to the left 1. Okay? So these, and this is a rough sketch. Let's do this one in blue. Okay. Now, remember, I know you're listening to everyone's responses. Be careful and build and learn and change if you need to. Ashton, what direction on that blue line do I shade?
Down.
Below it, right? So, yep, below it, I'm going to do below what I see, including the line. Whoops. So below what I see, including the line, let me shade. I don't know why it's not doing it. There we go. This means below. It doesn't mean to the right or left. Remember, it means below. And our answer is the one that's the double shade. Okay? So on your paper, you can make it a little bit darker than the other ones. However you choose to, just make sure that I can see. Some people even bring different colors, and they'll color the answer in a different color. Okay? Now, here we go. I'm going to put points, and you tell me, everyone, if it is an answer or not. Would this point right here where they meet be an answer?
Yes.
Yes. Would this be an answer? Yes. Would this be an answer?
Yes.
Yes. Would this be an answer?
Yes.
Yes. Would this be an answer?
No.
No. Would this be an answer?
Yes.
This?
Yes. Yes. No. No.
Okay, you're getting it. So the shaded regions and the boundaries are all answers. Okay? So give me some points. Olivia, what's the first point that you can make out of thin air that would be one solution?
5
5, 2.
2.
Perfect. Okay, Kendall, what's another one that you could make? 2, 0. Now remember, if I did this correctly, I can check my points by putting both of them, or both of these equations, I can put the x value of 2. And I could put both of them's y value to be 0. Guys, you can check your answers big time in this unit. So here we go, let's check it. 2 times 2 is 4, minus 0 would be 4. So you got to ask yourself, is 4 greater than or equal to a negative 3? Yeah. So, but you have to check both equations. So using the same point up here, we have 0 is greater than or equal to. And if I plug in this 2 where x is at, 2 times the negative 1/2 will give you negative 1 plus 0. Guys, is this true? Yeah. So those are solutions. Zach, let's get some non-solutions. Which one do you see? Negative 2, 0. Riley, what else? Yeah, negative 3, 0. And basically anything that's not in that shaded region for sure. Cool. Alright, so let's keep going. Let's do a second example. Our second example, these are my calculus notes. The second example will look like a word problem. Here we go. It's a pizza parlor, so already you can definitely relate and put yourself in the problem, especially if you like pizza. And I'm going to have two variables. I'm going to have y, that represents $1 for veggie toppings, $1. And I'm going to have an x variable that represents $2 for each topping that are meat toppings. Okay. Your stipulations are this. You want at least 5 toppings on your pizza. And then also, your second stipulation is you only have $10 to spend. And I want you to tell me how many of each topping can you get? Okay? This is the system of equations. You should be thinking 2 equations in your head.
Do you have to get at least like one of each?
Okay, so at least, oh, I see what you're saying. You do not. I mean, you can if you want, but you don't. That's an awesome question. That's a very, very good question. So Olivia's asking, do you need at least one of each? And you don't. You could have all veggies, or you could have all just meat toppings, which would be an awesome pizza. Let's come over here. And you have 2 equations. Okay, here we go. Let's label what they're talking about. Aiden, what would one of the equations be talking about? Like, how would you set it up? Help us set up one equation.
One of them have to do something along the lines of 2x plus y
So 2x plus y
is less than or equal to 10.
perfect. The equation he gave us is talking about money. Okay? There's another equation. Okay? Emeka, what would that one be?
X plus y is greater than or equal to 5.
Yep, x plus y is greater than or equal to 5. This is the number of items. Guys, I would say 99 out of 100 times it's going to be number of items and money. Okay, even on SAT and ACT. Now let's go ahead and solve this system by doing exactly what we did last time. Okay? Peyton, what would the first equation be in y equals mx plus b form? This one right here.
Y equals 2x plus 10.
Okay? So close. We're moving the 2x, but because we move it, it's got to be a negative because we're subtracting it to the right side. Okay? And you were listening carefully. What else did she say? No worries, we're fixing it as we go. That she would need to change what she said. Less than or equal to. Okay? So it's got to be less than or equal to instead of just equals. Okay? Because equals are all going to be lines no matter what. They're always going to be solid. Okay? Hannah, let's change the other one to y equals mx plus b form. And that might have been neat the way I just said y equals mx plus b form. Let's change the other one, Hannah, to solve for y and get y alone.
Negative x plus 5.
Yep.
Y is... Wait, does the sign switch?
It doesn't switch. Okay, put this in your notes if you don't know this. It only switches if you multiply or divide by a negative any time throughout this process of getting y by itself.
So then, greater than or equal to.
Yep. So y is greater than or equal to negative x plus 5. Guys, look at this equation. I'm going to read it 2 ways. Y is greater than or equal to negative x plus 5. The other way is negative x plus 5 is less than or equal to 5. Which one of those is correct? Gotta listen carefully. Which one of those is correct? I'll say them again. Y is greater than or equal to negative 5 plus, y is greater than or equal to negative x plus 5, or negative x plus 5 is less than or equal to y. They're both correct. But which one do I prefer? The first one. Okay? So, let's graph this real quick. Both of them will be solid, for sure. So, 1, 2, 3, 4, 5. Let's do this line in red. it has a down 1 over 1, down 1 over 1. So it's going to go through 0, 5, and 5, 0, and it looks like this. Okay? Lucas, where do I shade?
You do above.
Above. And I include it. Okay. Gabby, what do I do for the next one? How do I graph this one right here?
Place the point at a positive,
Yep, so go all the way to positive 10.
and then go down to over to the left one.
Close. We're going to go down 2, but then the right one. Because a negative 2 and a positive 1 will give me a negative 2 slope, which is what I have. Okay, so down 2 and then to the right one. Only because if I go down 2 and to the left one, it's actually going to be a positive 2. Okay, no worries, that is common. So down 2 over 1, down 2 over 1, so on and so forth. And it looks like this of some kind. Katie, what direction do I shade? So down or below this blue line and including it looks like this. I know this is a rough sketch. Here we go. Marcus,
Yes,
is
sir.
this an answer?
Yeah.
Who disagrees? Ethan, why do you disagree?
Wait, so you can't have that in?
No worries. Okay, so look.
Oh, I didn't see that when it was on the graph. I just saw the gray.
So all of these are double gray. They look like they should be part of the answer. But with word problems, we have to read and get out of this routine a little bit. And we got to ask ourselves what makes sense. Can someone tell me what the x-axis is representing in this problem again? Meat toppings. Can I have negative meat toppings? No.
You just get more fish to come.
Say again?
You just, if that doesn't work, what are you gonna do? Exchange the meat topping for more vegetable topping?
That would be awesome.
That'd be cool.
Yeah, so you're not going to have this. Whoa. This would not exist on your graph. The only parts that are going to exist is the y-axis and basically to the right. So my answers will be here, 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 and all the shaded region in between. You're with me? Conceptually, we're understanding it. Okay. Any questions before we do our last example? Okay. So our last example is going to find a system of a quadratic and a linear function. Guys, we're going to talk about quadratics all year. In quadratics, they look like parabolas. Almost like satellite dishes, if you will. Okay? So, here we go. You tell me. If I have these two shapes, how many answers could I have? If I have both of these two shapes, anyone?
How many answers?
How many answers or solutions could I have? Caitlin? I can't have infinite answers on this. We're not doing inequality. Okay, and that might have been my mistake. I'm sorry for that. We're just doing, whoops. We're just doing, that was cool, equals. Okay? So if I'm looking at just equals, Ethan, how many answers could I have?
0, 1, or 2.
Nice. Look at this. 0 looks like this. 0 answers. They'll never what? Touch. 1 answer could look like that. Okay? And then 2 answers could look like that. Can I have 3? No. Could I have infinite? Nope. Just 0, 1, or 2. Okay, cool. So now with that in mind, let's do our last example and then we'll do our CFA. Our example, it's not for grade. Example number 3 is solving a quadratic, that's this, and a linear, that's this, system. Okay? So the two equations that I want to give you are y is equal to x squared plus 3, that's the quadratic, and the reason why it's quadratic, whoops, is because it's raised to the power of 2. Okay? And those of you probably thinking about this, quad is usually 4. Some people think it should be raised to the power of 4, but we'll talk about that soon of why it's 2. Okay? And then the linear function that we're going to use is negative 4x plus y is equal to 3. I'm going to show you how to use the calculator in a bit too. Here we go. When you have, what method did we do last time that I said it's probably your best method, guys? It's the fastest by hand. Elimination, right? Elimination, 9 out of 10 times you'll use elimination. Very rarely would you actually, you still have to learn it, but will you actually use substitution? And this is a time that you should use substitution. When I have a line and a parabola, use substitution. If I have 2 lines, I would say use elimination as your first go-to. Okay? Here we go. Substitution, we've practiced it. Which one of these equations do you think I should try to get a variable all by itself? The quadratic or the linear? Which one? The linear one. Okay, so either one will work. I'm just trying to go the easiest route. Okay? So let's get this with one variable all by itself. Y is already by itself. So I'm just going to add 4x. Now this will be substituted in right here for y. Okay, here we go. So we have 4x plus 3 has just been substituted in for y, and it's equal to x squared plus 3. Did y'all see what I did? I solved for y on the linear function, whoops, on the linear function, and this right here, just like a sub goes in for baseball. The pitcher comes out, the sub goes in. Volleyball. Libero goes, no, libero doesn't ever come out, but I'm saying, you know what I'm saying. When you sub in, a person will come out and someone goes in. This one is subbing in and is now going to do y's job. So now the reason why I did that is because look, it's all the same variable now. It's easy to solve when I have one type of variable. Now we're going to get 0 on one side. Here we go. X squared minus 4x, and I'm going to subtract 3. So it would just be 0, right? So this is what I have left. You with me? Now, I'm going to show you how to do this by hand real quick, because you can do this piece. We've done it with other topics that we've already covered. What's the GCF of the right side? X. What would be left over? The GCF is the greatest common factor. If you don't know this, you've got to learn it quickly. The greatest common factor means both of these were divided by x, this one right here, because they both share that x. What will be left over here when that happens? X minus 4. You with me? So on the graph, x is equal to 0 and x is equal to 4, listen, are where these things will actually touch the x-axis. Watch me do this. If x is 0, this is 0, and 0 times anything is 0. Watch it one more time with the other one. If this is 4, then 4 minus 4 is 0, and 0 times anything is 0. Y'all with me? So my two answers are x is equal to 0 and 4. Now with the calculator, and then we'll go to our CFA, quickly follow me. We're going to show this as far as how you can find it graphically, and also how you can find it the shortcut way that I want to show everyone how to do. Okay? So home 2, menu C, okay, if you need to. Okay, I'm going to go ahead and sign in. And then I will show you what this looks like on your screen. Follow me closely. If you fall behind, just sit there, look pretty, and then watch the video later. 1 for new document, menu 1 for add a calculator page. Control doc, we're going to press 2 to add a graphing page. And whenever I got that equation that was all by itself, it said x squared minus 4x. Okay? So if I come over here and I put x squared minus 4x and I graphed it, you'll see that it crosses the x-axis at 0 and at 4. And if you wanted to use the graph, you'd go, watch me, menu 6, 1, because they're the zeros of the function. And it's asking you, what's the lower bound? If I go to the left of the first x-intercept, and then soft mouse scroll, you see, there it is, 0, 0. Watch this again with the other one. Menu 6, 1. And if I go to the left of this one, anywhere to the left of that right there, just to the left, and then soft mouse to the right, you'll see the other one pop up. And notice where my answers are. They're the x-intercepts, where x would be 0 and 4. There's an easier and a faster way. Check this out. The very, and this is only to check your work. Okay? We're going to type this into our calculator right here. Let me cover this in red. And we're going to do solve this for x. So just like what we've dreamed about a calculator to do as far as being able to solve exactly what is on our paper, we're going to be able to input that in real time right now. Okay, so follow me carefully. Again, if you fall behind, just sit there, look pretty, and look up here. Make sure you see the steps. So here we go. Go back to the first calculator page. And on 1, 1, I want you to go ahead and type in with me. We're going to solve for this variable. Menu. What number do you think we're going to press? 3. What number do you think we're going to press? 1. And now you're going to type in exactly the equation. What was the equation again? No, the equation that I had? 4x plus 3 is equal to x squared plus 3. Is that correct? Now, you have to tell the calculator what to do. You have to be smarter than the calculator. What variable did we want it to solve for? X. X, right? So we're going to do comma x. And when I press enter, there's our answers. 2 different ways. Okay, go to put your notes away, please. You do not need a calculator. Here comes your CFA.